Okay, good afternoon. Right. So today we'll continue with our topic 2, that is computer architecture. So we'll finish the topic 1 next class. Okay. Right. So let me show you which topics we will be covering today. Right. So last time we discussed the evolution or history of computing, including the first generation, second generation, and so on, and also classifications of computing. So today we'll look at uh, more details about the von Neumann architecture, right? Von Neumann architecture and different units in the computer. Of course, we have already looked at it, but we will look at it a little bit more detail. The fetch, decode, execute cycle, the ALU control unit, memory, data and control buses. Right? So those things will be covered. And also we will look at the memory hierarchy, okay, and the basics of registries and so on. But we will look at details about the hardware in the next topics. Okay. So you can see, so we will cover at the end of today's session, we will finish about 1/3 of the topic 2, right? 1/3 of the topic 2, because we have already covered this part. Last time we covered this one. Okay. Last time we covered this one. Today we'll cover these subtopics. Okay. These subtopics. So then we will need 2 or 3 more sessions to cover the topic 2. So then the topic 3 is representing data in the computer and so on. Okay, so we are going fast because we don't want to waste anyone's time. Okay, right. Right, so today's session is available in the Google Classroom. So from today onward, only students who are doing the payments, you are only having the only those are having the Google Classroom, and probably from next week, the the sessions will be only for those who have done this payments. Okay, right. So the note is available in the Google Classroom, so you can get it from there as under topic 2, computer architecture. Okay, right. So let's continue from where we stopped. So last time we did the introduction to computer. So we discussed that computer has the layered architecture, computer has the component. So last time we did the evolution of computer. Previously, we did the introduction to computer, right? So today what we do is we move on to the computer architecture a little bit more details. So basically, we go a little bit more details into what we discuss under introduction to computer. So that's it. So nothing much new things you will learn. Only thing is you will learn few things. We will go into little bit more serious. Okay. Right. So already we have discussed that the computer has the layered architecture, the hardware, firmware, software. So we will dig into more about that architecture in this session. Okay. Let's see whether we can finish it. Maybe we will be able to finish it, or maybe we can finish about 2/3 of this topic. Okay. Right. So overview of the computer architecture. So basically the idea is at the end of this session, you must have a fairly good or better understanding about how the computer process data, process input, process and store data. Right. So we look at this architecture last about 2 weeks ago also. Now you can see that you will be learning less and less things because we just build on the previous understanding and learn few. You will find that we learn only few things per week from this week onwards. So the first few weeks we learn a lot of things, but now we learn only small things Okay, right. So remember, we can look at the computer as set of layers. Of course, we can't see it for our eyes, but it's architecture. Architecture means how we look at it to better understand something. So we can look at the computer as hardware layer. On top of that, we have the firmware layer. And on top of that, we have the software layer. So that is how we understand. For example, even humans, right? So we have the physical things. So then there's something called mind, right? So we can think, we can remember things, right? We can control things with our mind, right? So there's something like mind and body, right? So this is something like your mind, but mind is not a complete word, mind and brain, because brain also has some sort of a uh, energy. So your hardware and firmware is something like your physical body, right? So or you can say something, sometimes religiously we can call it soul, okay, religiously, but we, if you take it as a scientific way, we call it our mind and our brain, okay? And also brain also has both physical things and non-physical things, okay? So similarly, we have the software here. So hardware is the hardware parts. The firmware is technically software, but more related to hardware. So then you have the software. Okay, we'll take one by one, a little bit more details today. We already took one by one, but we'll take more details today. Right. So what is hardware? So you must have very confident answer if someone asks what is hardware of a computer. So hardware of a computer includes the physical electronic parts. Okay, or if you want, you can even take the non-electronic parts like your plastics and so on. But let's forget about those things like casing and so on. So when we say hardware, so we are interested in the physical electronic parts, right? Physical electronic parts, that is processor, hard disk or your SSD, monitor, and so on. Okay, so why do we need hardware? So hardware involve all kind of things. For example, we need hardware for input like keyboard, mouse, hardware for output like your screen or monitor or printer, hardware for storage, hard disk, SSD, pen drives, and obviously we need hardware for processing, that is the microprocessor. And also we need hardware that bind these things together. So that hardware component or hardware is called the motherboard, right? So basically hardware includes input devices, output devices, storage devices, processing devices, and motherboard, and any other supporting device. And we have already discussed that the computer hardware use component architecture. So that is a good thing. So computer has been designed as set of components, well-defined components. Each component does well-defined tasks, and they communicate and collaborate using well-defined interfaces. So that is why we can easy to troubleshoot a hardware component, easy to replace, easy to upgrade. We discussed that. So this is not something new for you. Okay. Right. So that is the overview. Later we will take input output devices. That is not today, in a separate session. We will take input and output devices separately, storage devices separately, right? What are the different storage technologies, and also processing part separately. So today we look at the overview, because the today's topic is computer architecture. We are not going into details about components. We stay in the high level. Okay, big picture, right? So once you first you have to look at the big picture, and then we can look at each and every part in detail. Okay, right? So that is your hardware. Okay, hardware. Input devices are there, output devices are there, the processing devices are there, storage devices are there, and of course the motherboard is there, and there are some other parts as well, like there's a fan and so on, right? We will look at those things separately. Okay. But so you must know exactly what is meant by hardware of a computer. Okay. So then we have the firmware. So firmware sits in between hardware and software. So this is basically the software, and this is hardware. You can see that the firmware is in between hardware and software. So that is why we use the word firmware also. So hard means tangible, physical. Soft means non-tangible, cannot touch. So firm literal meaning is not as hard, and but not as soft, right? So that is something like that. Okay, so the meaning. But technically, firmware is also software. Okay, so then someone will ask, if firmware is also software, why do we call it firmware rather than software? Yeah, it's technically it's a software, but this firmware is tightly bind to the hardware. Oh, it's basically driving your hardware. So sometimes we call them the drivers. Okay, drivers. So because this software is very much bind to the hardware, specific to the hardware, we just call it firmware. That is one reason why we call it firmware. There's another reason why we call it firmware. Uh, Most of your firmware is in your ROM, right? Read-only memory, which used to be read-only. That is why we call it read-only memory. So that means the manufacturer write that software. I told you it's technically software, but we can't change it. We can't change it as our end users in the computer. So therefore, it's very rigid, right? It's very rigid. We don't have the same flexibility as software, because at any time we can install and uninstall software. We can even uninstall and install the operating system. But because this is in the ROM, it's not easy to, or it is not our task to change it. So the manufacturer supposed to do the changes and so on, because it is something to do with the hardware. So that is another reason why we call it firmware, right? Because it's not as soft, it's not as flexible as software. And that is why it used to be in the ROM, right? ROM means read only. Computer can only read, manufacturer write. So that is another reason why we call it firmware. So I gave you two reasons. One is this is very much bound to the hardware. So therefore we just call it firmware. Second one is this is not something that we frequently upgrade, erase, and so on. So therefore it's sort of a very rigid, though it's software, we just call it firmware. But the term read-only memory these days sort of a misleading, because these days even the firmware can be upgraded, right? Firmware can be upgraded. So therefore now these days firmware looks pretty much like software, right? Pretty much like software, but still we use the word ROM, though it is not no longer ROM, and also we use the word firmware. Right? For example, if you are looking at your Windows updates, if you are using a Windows computer, so you have to look at those things practically. Right? So if you go to your settings and go to your Windows updates, if you are using Windows computer, and you can go look at the update history. Right? And you will clearly see that some of those are operating system updates, operating system virus guards, and so on. But again, you will see that there are some updates which are, where is that? Let me show you. Yeah, this is 7.12. Yeah, you can see drive updates. So these are firmware updates. You can see Intel corporations. Some of those are coming from Dell, right? So you can see the word Dell in firmware, right? You can see sometimes they call it software component. Sometimes they use the word firmware. right? So firmware for the processor, firmware for Bluetooth, right? Some systems of firmware, you can see sometimes they use the word firmware. You can see these are getting updated, right? So this is the date last updated, last installed, right? So therefore, I told you no longer. So another name for firmware is something like drivers, but not all the firmware is driver, right? So therefore, these days, though we call it uh, firmware, it is pretty much like a software. We can upgrade and so on. Okay, but still we use the word firmware because it is pretty much bind to the hardware, or it is basically driving or running your hardware. Okay, so that is a, so sometimes you will find it difficult to understand what is this. You can understand what is hardware, you can understand what is software. Sometimes you get confused what is firmware is. So the way to understand is technically firmware is a software, but for two reasons we call it firmware. First reason, it is specific to your hardware and it is closely working with the hardware. So that is one reason why we call it firmware. The second reason is it used to be in the ROM and we were not supposed to change it, right? Update it. So therefore, historically, we call it firmware. But these days, though we still use the word ROM, they are no longer ROMs, right? We can upgrade your ROMs and so on. So actually, you will learn a different type of ROMs that is in your syllabus, like programmable ROM, electronically programmable ROMs, and so on. So therefore, these days, the firmware is typically in the ROM. Partly it is in the ROM, partly it can be in the your SSD or hard disk. Even those in the ROM, the firmware in the ROM can be upgraded. Okay, so therefore these days firmware is getting more and more like a software. Okay, more and more like a software, that the flexibility is there. Still, because it's running your hardware, we just separate it as firmware. Okay, from software. Right. So as I told you, so why do you need firmware? There's a special reason. So I told you that firmware, another name for firmware is drivers. Right, drivers. So just like a driver drives the car, right? So for example, if you take a vehicle or car or something, so this is your car, but you need someone driving it, right? Maybe others are passengers. So so therefore your firmware is something like the driver, right? Something like the driver that drive the vehicle, that drive the vehicle. So in this case, your firmware drive your hardware, right? Drive your hardware. So that is how you understand it. So then someone will ask, we have operating system, right? We have operating system. So operating system is also doing similar tasks, right? Similar tasks. So operating system is there to operate. So therefore, someone will ask, why can't the operating system act like the driver? So remember the word operator. So if you take a vehicle, the operator is the driver. But in this case, we have two operators, the drivers or the firmware and operating system. So if you are a critical thinker, if you are someone who don't accept things for granted, rather you questions and ask for reasons, so then you must ask, why do we need two things? Of course, we can understand the application software that is to do specific things like our Word software, uh, like Photoshop software and so on. So then you can say, okay, I can understand the use of operating system which operate your system. So then the hardware. So then someone will ask, why can't operating system drive the hardware? So why do you need another layer called firmware? So that is a valid question. That is a valid question, and you must have an answer for that. So that is what is meant by education, studying. So studying is understanding things. Studying is not collecting questions, collecting headaches, right? Memorizing things that you don't understand. So that is not education. That is a stressful thing. So your task as a student is, if you want to really study, you have to clarify things. You have to build your confidence, right? You must know things, right? So therefore, so let's see why we need a firmware. Can't our operating system do this? Right? Can't our operating system do this? Running the hardware. So there's a reason. There's a reason. Of course, the firmware has many reasons. One of the biggest reason is, remember, we have different operating systems like Windows operating system, Linux, right? And Mac operating system and so on. So then we have different hardware vendors. For example, if you take the processor, because the processor is the most important component, hardware component, we have the Intel, right? We have AMD, we have Motorola, and Intel also different processors, i3 processors, i5 processors, i7 processors, at AMD 3 processors, AMD 5 processors, and so on. So you can see that, but you don't have separate operating system. For example, you don't have Windows operating system for Intel, or Windows operating system for AMD, or you don't have Windows for i3, Windows for i5. You just have Windows 11, right? So whether your processor is Intel or AMD or Motorola or i3 or i5 or i7, you just download and run, use your Windows 11, right? So, so you can see that the same operating system can you run different hardware, right? Whether it's an Intel processor or AMD processor, of course they have differences. The way Intel processor work is not the way AMD processor work. The way i3 processor work is not the way i5 processor work. So it's different technologies, right? So now you can see that, and sometimes these microprocessor versions comes after operating system. So after Windows 11 is released, maybe they will release i9, i11. Okay. So then by the time the Windows is already released, or the Linux particular Ubuntu version is already released. So then your operating system is expecting certain features, certain way of behaviors from hardware. But actually the hardware can be different, the behavior can be different from your operating system's expectation. So that flexibility is there for hardware vendors, hardware manufacturers. So therefore what firmware does is, or one of the tasks of firmware is give that compatibility. So this is a nice diagram showing that. So this is not a technical diagram, this is just a conceptual diagram. Say this is my expectation of my operating system. So we just put up the expectation into a diagram, right? And maybe this is how the hardware is manufactured by a particular manufacturer, say Intel. Right? Intel. Right. So again, the expectation is the same operating system. You can see the same operating system, same expectation is there, this component is the same. This component is the same operating system, but maybe now I'm using a different hardware, maybe AMD processor, right? Maybe AMD processor is designed, you can see this component is different from this one, right? Differently. But say this is my Intel processor, Intel i5 processor, this is my AMD 5 processor or AMD 3 processor, but the same operating system can be used for AMD 3 processor or Intel i5 processor. But you can see that this is the expectation, but this is how Intel has done it. This is the expectation, same expectation, this is how AMD done it. So how does Intel present their processor the way Windows expect? There's incompatibility. We can't fit in, these two cannot fit in together. They are incompatible. So that incompatibility is because this is hardware, manufactured hardware. So Intel present the processor the way operating system is expecting with the help of firmware. Right? With the help of firmware. So the firmware present your hardware the way operating system expect. Okay. So similarly, AMD, together with their processor, they release their firmware. So their firmware make the present their microprocessor the way operating system expects. So therefore, this firmware is different from this firmware. This is firmware, say, supplied by Intel. This is the firmware supplied by AMD. And obviously, the two processors are different. But with the help of the firmware, they present their processor into the operating system the same way. Same way. So therefore, firmware is something like a compatibility layer. One of the use of firmware is, or the driver present your hardware the way operating system expect. So therefore, for that kind of hardware, you need the hardware and the driver. Hardware and the driver. So the driver present it the way operating system expects. And sometimes the operating system provider has the default drivers. Right? Default drivers, because they also know that these guys are there. But sometimes the default driver work, but sometimes you prefer the driver provided by your hardware manufacturer. If it is latest hardware or more up-to-date hardware, your operating system may not have that driver. Okay, so that is what your firmware is doing. So it presents the hardware the way operating system expects, because otherwise you don't know, right? You just memorize things and go to the exam without any confidence, right? Because you don't know if someone asks what is the reason for firmware, so you must explain to that person this is the reason. So the firmware act like a cushion, the firmware act like a compatibility layer, right? Compatibility layer. And most of the time that is why firmware is given by the hardware manufacturer. Okay, hardware manufacturer. But if the hardware manufacturer's firmware is not there, operating system also keeps certain drivers and see whether they can use that general driver. But sometimes you may have seen it says there's a better driver. Or if you have that issue, try to download an up-to-date driver from your hardware manufacturer, right? So that is you get more compatibility. Right? Maybe operating system can do it, but operating system may do it better if you have the better driver. Okay, right. So that is one of the use of firmware. Present the hardware the way operating system expect. So that's part of, because firmware is not just one thing, firmware has set of things. So this compatibility layer or the driver layer is called the BIOS, right? BIOS. So basically firmware consists of few parts: the BIOS, CMOS, microcode, and some other firmware in the other devices. So this is basically the system firmware, the main firmware in ROM. But there are some firmware in different devices. For example, there can be firmware in your network card, right? So there can be firmware even in your monitor. Okay, but this is, we are talking about the main firmware, which is more related to the processing. So what are the three components? BIOS, or basic input output system. So this is the one that gives you that compatibility between hardware and operating system. And the CMOS is there. We will look at what is CMOS, and there's another part called microcode. So this is basically the firmware in other components. Okay, like your NIC, network interface card. Okay, so when you buy a network card, right, don't think that you have only the hardware. So it has a small chip. Inside that there are some drivers, right? Drivers. So that is the firmware for your network card. Okay, but this is your main firmware, or firmware in the ROM, read-only memory. Okay, we will look at what is read-only memory in a little bit more details later. And if you have any questions, you need to ask, because your task is not collecting doubts. your task is not collecting something you don't understand. Your task is collecting confidence. Your task is collecting understanding. Okay. Uh, so those who collect understanding, confidence, they are getting more and more happy, more and more relaxed, right? More and more, right? Uh, prepared for the exams. Others will be more and more stressed, more and more, right? Uh, they are not confident. They are very backward minded because they are collecting things that they don't understand. Okay, so don't get into the part type B. Be a type A person, type A student, right? So now if someone asks what is BIOS is, the BIOS present your hardware the way the operating system expect. Or basically those are the drivers. Okay, those are the drivers. Okay, so if my operating system is something like this is just a hypothetical or theoretical thing, something like this. Say this is also the same operating system, but maybe my hardware one is something like this. Maybe my hardware 2 is something like this. So this firmware layer provided by hardware vendor 1 and hardware vendor 2 make it compatible. Make it compatible. Okay. So that is what BIOS is doing. Right? Basic input output system. Basically, BIOS are the system drivers. Okay. Basic drivers. Right. So then we have CMOS. Now remember BIOS means what? Basic input output system. BIOS, BIOS, right? So then we have something called CMOS, right? CMOS. So CMOS stand for complementary metal oxide semiconductor. Don't think too much about these words. These words were put up in 1970s, 60s, right? Old words, just like our grandparents' names. They were very lengthy, cryptic names, okay? Very technical names. These days, we just use the very simple words, but unfortunately, these words came in about 40, 50 years ago. So therefore, they are pretty lengthy, right? BIOS. So in 1940s, 50s, their preference was give them bigger words and then use the acronyms. So remember we discussed about ENIAC, EDSAC, UNIVAC. The computers were also given like that. Even IBM computers, right? But these days, now we are, so that is how the people evolve. The modern humans like simplicity. So that is why it's no longer ENIAC, EDSAC, UNIVAC or CMOS or BIOS. Now we talk about Dell, Apple, right? So that is how we give the names now. Okay, processor, right? We don't like the word CPU anymore. Central processing unit. We just say processor. So the world is going towards appreciating simplicity. But these names came in 1960s, 70s. So therefore, whether we like it or not, we have to use this word. Okay, so the first word is BIOS. That is the first part of the firmware. The second part of the firmware is called CMOS. Complementary metal oxide semiconductor. So you have to remember this, unfortunately, right? So this is where your BIOS preferences are saved. Right? So some of you may have done this in your laptop or your desktop computer. Sometimes, especially boys, most of the boys knows this because they are, especially if you are working with games, installing software, you install your own operating system and so on. So definitely you know what is the screen is, right? So for example, when you switch on your laptop or desktop, initially there's a black screen, right? Then after sometimes you will see maybe starting Windows or something like that and getting into that Windows screen. But the moment you switch on your computer, the initial screen, right? So basically at that time, your operating system is not yet come to work. So it is not started. So at that time, basically your computer is under the control of your firmware. Your firmware, basically under the control of your BIOS. right? And there you have options. If you want, you can just look at it by switch on your computer again. There's a black screen initially, and there's a particular key combination. They will say, if you want to go to the CMOS settings or your BIOS settings, you have to press this particular combination. Maybe something like F7 or F11 or something like that. It depends on your computer, right? So usually that message is there. Most of the time now you don't see it because now the computer boot up very fast. Sometimes you don't see the screen. But when we first use computers, so I first used computer in somewhere around 2000, right? Somewhere around 1999. At that time, that screen, that black screen is there for at least 15 seconds. And then it boot up the operating system for another closer to 1 minute. So that is how the old days of computers were. So at that time, we were heavily aware of these things because we can see that screen. But these days, you don't see that screen much because the things are fast. But still, that screen is there. That screen is there, right? So that is basically your, if you want to get into your CMOS settings or BIOS settings, you can press that key combination and you will get something like this, or it can be blue or black or whatever. So there you can do some settings or change some settings. Like you can decide your system clock time. If you want, you can change the system password there also. That is system password, the master password for the entire system, not for your Windows password. You can have a separate password there. And also you can change the boot up sequence, right? Sometimes you want to boot from a CD drive. So those things you have to go and do those changes. So we call it, so those preferences are saved. So that next time also when you boot up the computer, it must be remembered. So those are saved in CMOS. It is also part of firmware. So your preferences, user preferences related to firmware is saved in a component or hardware part called the CMOS. So CMOS is also technically firmware. So BIOS is for firmware, CMOS is also firmware. So that means CMOS is not saved in your hard disk or SSD. So therefore, even when your hard disk is crashed, your SSD is crashed, still these preferences are there. So the reason is it is not saved in your hard disk or SSD. It is saved in a separately in your ROM. ROM is in your motherboard. Right? ROM is in your motherboard, and not only that, it has a battery power. So there's a very tiny battery. Usually, it lasts for at least 7 to 10 years. So therefore, you will almost never ever see that the battery is dead, right? These days. But for example, when I bought my first, right, when I bought my first computer, I had to replace this battery. I had to replace this battery, right? Because at that time, about 2 3 years, once in 2 to 3 years, we have to replace this battery in the motherboard. But these days, you don't have to do that because the technology is far superior. So these batteries last for about 7 to 10 years now. Okay, but this battery power is needed to keep that your settings, preferences in the motherboard, you're saved in the motherboard. Okay, right. So now we discussed two things. One is BIOS, that is basically your drivers. That is the main firmware, which is provided by your hardware vendors. Then we have the CMOS to save your preferences, user preferences related to the hardware, right? Related to hardware. So those are the two main parts when it comes to firmware. So next, we have firmware for other hardware components. So far what we discussed was the system firmware or the firmware in the ROM, right? Firmware in the ROM of your motherboard. But when you have your network cards, graphic cards, right? Maybe they also have their own firmware, right? They can have their own firmware. So that is basically driving that particular component, right? Driving that particular component, that particular, say, graphic card, or driving the network interface card. Okay. So, and also there's a concept called MAC address. We have the networking as a separate topic later. So this MAC address is also set up by your hardware manufacturer. It's an address. So that address is also kept in the firmware of that network card. So therefore, so we have now the main firmware or system firmware that is in your main ROM. So then your other components can have its own firmware as well, or the drivers as well. So those are basically drivers for that particular hardware component. So those drivers are stored in your hardware components. It has a mini ROM, and it can be accessed by your operating system. Okay, right. So those are the three parts of for this. This is specifically for the other hardware components. The two main firmware parts are, or firmware components are, or type of firmware are BIOS and CMOS. So BIOS are the major drivers, like drivers for your processor and so on. And also you can look at it as a compatible layer, presenting your hardware the way operating system expect. Then the CMOS is to save the user preferences. And then there are firmware in the other components, okay, like graphic cards, network cards, and so on. So any questions on firmware? Because we don't look at these topics anymore. So this is the day we look at firmware. Because later on we are going to look at some other subject like programming, database. Right? Therefore, if you have any questions about firmware or any other, you can ask from me, you can do a Google search, you can go to YouTube and search what is firmware, right? No one is going to, right? So when we were studying, so we were relying on teachers and books. But you guys are not 100% relying on us anymore. So we can give you the guidelines. So then no one is going to control you learning to the depth that you like. Right? For example, I can still remember when we did A-level, right? Sometimes when you go to the library, because there was no internet at that time. Right? So when we have problems, if our teachers cannot give us proper answer, or in simple, if you can't understand the subject when the teacher explained it, so we were helpless. So then we had to go and read the books. Sometimes the book, so we are looking for a particular book, the book is not there in the library because it's a so demanding book is rarely in the library. So then we have to reserve the book and come home. So then if it is a public library, we get a postcard saying the book is now available. You have to come and get it maybe within 5 days. So then only we get the book. Again, we can just keep it for maybe 2 weeks. Maybe they allow us to renew another 2 weeks. Then we have to again give it. Right? So that is how we learn. But you have so much of opportunities, right? No one is going to control the depth of knowledge you want. It's driven by your motivation. Okay, right. So that is firmware. Right now we look at briefly hardware, and also we look at firmware. Right. So now we move on to software. So this is not something new to you guys. So you are pretty much familiar with what is software is, right? So software is basically the programs. Okay, programs. So sometimes we use the word software, sometimes we say program, right? Casually, we say programs, especially the IT professionals. When we develop something, we say we develop a program. But others will say, it's software. Yes, it's a software, it's a program. Right. So the software is the soft part because it is not a hard thing. It is not a rigid thing. It's something like our soul or our mind. Okay. Something like, right? But the word mind is terribly misleading, but it's a soft thing. It's a soft thing that software developers develop, and they will give it to you, or they will let you download, or you can use a pen drive and you can install it. Then you can use it. Now, for example, this is a software I'm using to write something, right? So this is software which is installed uh, in my computer, and I'm using it. At any time, I can uninstall it. I can upgrade it to the new version. So another software I'm using right now, Zoom. Another software I'm using right now, that is PowerPoint, right? So right now I am using Windows operating system. So Windows operating system is also software, right? You can see that those are all what? Software. So you can't touch software, right? I can't touch. Of course, you can touch a CD containing the software, but software is a conceptual thing. It's a code. Right? It's a code. Okay, right. So we can subdivide software again into two categories. So what are those two categories? System software and application software. System software and application software. So let's look at the difference. So this is just for our convenience of understanding. Okay, we just divide it, but technically software is software. Okay, right. So remember, in layered architecture, so we draw system software just above the firmware. Then on top of system software, we draw the application software. So that means system software is lower level, application software is more higher level. So application software is more closer to the user. System software is more closer to the hardware, or it sits in between application software and firmware. Okay, so likewise, you have to understand this. So what you have to be is you have to be serious person. Right? Serious person. So that is why we call this advanced level, right? So we expect you guys getting out of the ordinary mindset and be more serious. So look at things, right? Why it is called software? Why do we have two components, right? Okay, system software is sitting in between application software and firmware, right? How does system software is related to application software? How does system software related to firmware? Right? What are the system software available? So that is your task. That is called studying. Right? Studying. I told you in Sinhala there are two. One, there is a terrible word called padangan. So that is, I don't know how come that word came. So addhyayane karna. Study means addhyayane karna. So you see how they are related. Right? It's an active task by you. It is not someone's note you just keep memorizing. So that is terrible thing student can do. Right? Of course, you may be able to pass exams, but you will not be able to do anything out of that. Okay. So think about those things. Analyze those things. Okay. Right. So we can subdivide software into two categories. That is system software and application software. Right? System software and application software. So system software is the lower level, which is closer to the firmware, right? Sit on top of the firmware. Application software sits on top of the system software. So let's first look at system software. Okay. So when it comes to system software, so easier thing is understand the application software first. Application software is basically different applications, right? Different applications. Right? For example, I'm using this application now. Okay, I'm using PowerPoint application. I'm using Zoom application. I can use Photoshop application. I can use Word application, or I can use a game application, computer game. Right? I can use WhatsApp application. So those are applications. So basically, why we buy a computer? Because we need those applications, or we like to use those applications. Or if you take a business scenario, maybe they are having a billing system, right? Order processing system, student management system, right? So those are all applications. So you can see that applications can be used for business purposes, or applications can be used for personal purposes. Okay. So, for example, your smartphone has so many personal applications software, right? Some of those are used for communication. Some of those are maybe your address book, a computer game. Okay. So those are all application software. So application software is used by the user or the liveware. So that is why we buy a computer. We buy a computer not because we like hardware, not because we like firmware, not even because we like the system software. Of course, when you install your operating system 1 or 2 days, you will feel like, yeah, okay, so that is nice and so on. But after sometimes you forget about your operating system, right? You log into your computer or you use your mobile phone not to play around with your Android. You want to use your application software. Okay, right. So now let's look at the system software because it's easier to explain system software once you understand the application software. Okay. Right. So what is system software? So remember, application software is different applications, personal or business applications. Those are the on top of software. Those are the software that we really want to use. That is why we buy a computer. So then system software is other software or more low level software. So we can identify three categories. So basically system software means software that we use to do the basic system operation. So that is why we call it system software. So this is pretty much close to firmware, right? So sometimes it's difficult to differentiate between system software and firmware, but firmware is lower level system software, more close to the hardware, right? So little bit high level system software is called the system software. Okay, right? So system software we can identify into three categories. What are those three categories? The main system software is operating system. Actually, when you have a computer or smartphone or laptop, the main software is operating system. So that is why we call the word operating system. Right? So operating system operate your hardware, manage your software, other software, okay, manage your files, and so on. So that is your main software. So therefore, main part of system software is operating system. That is obvious, right? Main part of system software is operating system. So what are the tasks of operating system? Manage hardware, manage software, right? For example, if I want to install a software, I use the support of the operating system because software is under the operating system and it runs the other software, manage files, right? So why I have not mentioned those things because you have a separate subject called operating system. So basically your fifth topic is operating system. So now we are into the second topic. The third topic is representing data in the computer. Fourth topic is processing or the logic. The fifth topic is operating system. So therefore, we'll look at in detail about operating system tasks, how it manage hardware, how it manage files, how it manage software or the processors. Right. So it's a big topic, big topic. So therefore, we'll look at operating system separately because we have that as our fifth topic. Okay. But when it comes to system software, there are some other softwares also which categorize under system software. Those are system translators and other system utilities. Okay. So system translators are used to, now remember, you have also one of the topic that you have in A-level ICT is programming. Right? We will be using Python. Okay. So then you have the web development also. There we will be using PHP and so on, JavaScript and so on. So these code we write as programmers. But this code is not understandable by your computer. Computer in the sense hardware, because computer is a binary device. It can understand your data as binary, and also processing instructions are also binary signals. So therefore, the program that we write, we don't write this kind of a program anymore. Of course, that is how we used to do it. Remember, we discussed the evolution of computer. We discussed that the people use punch cards. So basically, punch card is having a punch or not having a punch. Okay. So maybe here we have punches like this, but here maybe we have punches like this. So that is this punch. If the punch is 1, not having a punch is 0. Okay. So yes, we used to write our programs in binary, but that is in 1940s, which was very complicated, difficult task. But no longer we do that. We write our Python code, Java code, C code. But this C code, Python code cannot be understood by your computer. So therefore, we need translators that translate our code into machine code. So that is not happening in a single step. It happens gradually. Now, this is a very important thing you have to understand. Okay. So when we write our program in Java, C, Python, it doesn't all of a sudden translate it to set of ones and zeros. It translates in steps. And different programming languages use different translators, different type of translators. Right? So Python use one particular translator, Java use another one, C use another one, and also they use different approaches. Right? So those translators are also considered as system software. Okay. So if you are using a translator to translate, obviously we'll be using a translator for translator of Python code. We call it Python interpreter. Right? So those are also considered as those translators that convert our programs gradually into machine code or machine level signals. They are also considered as system software. Right? So now we have two types of system software. Operating system is part of the system software. If you use any translator software to translate our code to the machine code in different steps, we call them again system software. Those are also considered as part of the system software because those are also fairly low level, okay, low level, not applications. Okay, right. So the third category is under system software, other system utilities. Now you look at the word utility. So you try to understand, right? Remember, the more you understand, less you have to remember, more you are happier. So that is what we need, right? So you need to be. So I don't think that you like to have a lot of things to remember when the exams are nearing. So those who try to memorize rather than understand. So when the exams are nearing, so they get really stressed. They get really stressed. And sometimes they get blank. So sometimes their parent says the student is blank, like a short circuited. Sometimes they take the student to the doctor or psychologist, saying that the student is saying nothing is remembered. Why? Because they try to keep memorizing. There's a limit, right? There's a limit. So therefore, your task is understand, right? So therefore, first try to understand what is mean by system utility, right? So utility. So for example, if in your day-to-day life, we use some utilities. For example, we use spoons. We use knife. We use a broom. We use an umbrella. So those type of devices are called utilities, right? Utility devices. So these things are not because we use those things not because we like to use it, because those are our utilities. These are the things that help us doing our day-to-day tasks. Right? So I don't think that anyone clean their room because they like it, but whether we like it or not, we have to do that. So therefore, groom is a utility. But if you have a cricket bat, that is not a utility. That is application. If you have television, right, that is not a utility. That is application. So you willingly go and watch cricket match. You willingly, right, play cricket. You get some pleasure, right? You don't get any pleasure by, right, cutting something, using umbrella. You use it for survival. So utilities are like that. Utilities are like that. Whether we like it or not, we need those for our survival, our well-being. If you have that kind of software, we call them utility software, right? Utility software. Okay, right. So what are those utility software? Of course, the operating system and system translators are already covered. So therefore, we don't have to take those because those are already covered. Other utilities. Okay, so basically operating system is also like utility. We don't use operating system because we like it. Because we use operating system because without that we can't run our applications. Okay, right. So therefore, other than the operating system and system translators, what are the other utilities? So you can have the security utilities, right? So it's same as if a particular office or house has a security person, not because we like that person, right? Because we have to survive with other issues. So same thing, your computer may have virus guard, okay, or any other security related software. So those are part of the system utilities. So then maybe network management utilities, maybe your disk defragmenters, file zip like WinZip, WinRAR, right? So we need to sometimes make it smaller, right? Make it compress, right? You need virus cards and so on. Right? You need to defragment your disk, restore your disk, and so on. Those are also part of the system software. Now you know three categories of system software. Obviously, the operating system is system software. System translators, we will be using these translators when we are doing the programming and web development. Those are also considered as system software. Any other utility, not application. Not the application like security related or managing the our computer, like our files, disk space, right? Secure our computer. So those are also other system utilities, right? So then you don't have to memorize. You know why it is called system software because it is lower than the application software, and it sits between application software and the application software and the firmware. And what are the three categories or three type of system software? Operating systems, system translators, and other system utilities. Okay, because the former two are also utilities, but that is why we call it other system utilities. Right. So now we discuss hardware, firmware, system software, and of course application software we already discussed. The applications that we use, right? Applications that we use. So it can be business related or official applications or our casual or personal private applications like chatting, sharing of files and so on. Right. So that's it. And of course, we don't look at the liveware because liveware is the users. Right? So users are just using it maybe for their personal use or official use, like a business user. Okay. So maybe you are using it as a personally. You take a particular chat with someone, or you use it for transfer money or pay a utility bill. Okay. Like electricity bill. Right. So those are the application software, and then the liveware or the users. Okay. So remember, this is in the now we look at those things in the first round, but at very high level, summary level. That today we revisit it and try to go a little bit depth. So today you must have better understanding of what is firmware, because in the very second day also we look at this, the layered architecture, but we didn't go into the details. Today we went a little bit more details, and we have another round of going through these things: input devices, output devices, storage devices, in more details, maybe next another class. So then the second part topic will be over. Right. So we'll take about 3 minutes of a break. So then we'll continue with our architecture. Okay. So now it is 5:08. We'll be starting at 5:12. Okay, so let's continue. Fine. Fine. So overview of data presentation and processing. Remember, our third topic is representing data in the computer. Our fourth topic is processing data. Okay. So therefore, this is just an overview or make you prepare for your topic 3 and topic 4. Basically, that is what we do because we want to start the topic 3 and 4 pretty soon. Okay. So we can see we gradually make you closer, familiar to the next topic while we are doing the previous topic. So that is how we do it. Okay. Right. So now already you know that for computer, everything is binary number. Okay. For us, numbers are one particular concept. Characters or letters are another concept. Right. Image is another concept. So you can remember a scenery. You can recognize your house. You can recognize someone. Is it by using ones and zeros? No. Right. You can recognize someone's voice. You can sing. You can see a video. Right. You can see things when you move. So those are different concepts. Those are different concepts. We look at these things as different concepts, and actually we have very little understanding about how we understand an image, how do we understand audio, video. Of course, we know that we can see through our eyes, but when we see it, how do we recognize it? Right? How do we recognize different colors? How do we recognize different shapes? How do we remember these things? Actually, it's a big puzzle for us. We have very little understanding about how we remember it, how we recognize it, how we process it as humans. The funny thing is, we have very little understanding about how we remember and process these things, but we have built a computer which does almost all of these, and we know 100% how it does it. Right? How it does it. So that is why the computer is a funny device, right? So we don't know how we do it exactly. We have some sort of a vague idea. But at the same time, computer engineers, scientists, right? Electronic engineers have built a computer which does almost all the things. And now we are introducing the AI also, intelligence also into this. Right? So for us, we represent these things differently. For us, image is different from audio. Audio is different from text or alphabetical letter. It is different from a number. For example, number 5 has a different meaning than P. Okay. But when it comes to computer can also understand numbers, text or characters, images, audio, video. They can store it, they can process it, right? They can output it, input it. But there's a difference here. For computer, everything is ultimately set of ones and zeros. Your numbers are set of ones and zeros. That, of course, you can understand because there's a number system called base 2 numbers. But not only that, when you say hi, what you're sending is set of ones and zeros. So what is stored is set of ones and zeros. Your images, when you take a photo using your camera, so how do you save it in the computer? Set of ones and zeros. When you record someone's voice, right? So for example, when I talk, you can hear. So basically what is recorded or what is released from my computer to the internet is set of ones and zeros, which is converted back to audio signal that you can hear from the your earphone or speaker. Of course, when I talk also, I'm what is analog signal is going there, but that analog signal is converted to set of ones and zeros in my sound card. Okay. And then that one is again converted back to another analog signal by my network card, because in the network we have to send this kind of signals. And you can see that it's converting from analog to digital, digital to analog. So that is why you have the network subject. That is why you have the data representation. But ultimately, if it is stored, it is a number. Basically, my voice is converted to set of numbers, and then that to represent that number, another analog signal is created. That is a radio wave. Or in my case, I use fiber optics. It's a light signal, but maybe in the middle, that light signal is converted back to a radio wave, because maybe you are using wireless, right? I am using wired fiber optics, but maybe you are not using fiber optics. So then again, it is converted to a different analog signal. So those things we will be learning when we are doing the networking. So it's a long journey. So this is just a starting. So the first thing you have to understand is, in this session, for us, these are different concepts. But for computer, ultimately, any of these can be represented as set of ones and zeros. And how to do that, we will be looking at in our topic 3, representing data in the computer. Okay. So that is why we say computer is a binary digital device. Right? Binary digital device. But if you have seen, right, early days, I don't know whether you have seen, there was something called cassette pieces. Cassette piece with the tape and so on. And also there was something called deck. Now you have the computers and now sometimes the CD or DVD players. But we had something called deck. So there also we had something like cassette piece, a bigger one. Magnetic tape. But that there, our audio, video is saved not as ones and zeros, in a different format. So therefore, those were not digital devices. Those were analog devices. Actually, the understanding that technology is more difficult than understanding this, how the computer represent data. So that is why, so the people make it simple, not make it complicated. Okay, so don't worry. Understanding this, how to represent data in computer as a set of ones and zeros, is not a difficult task at all. It's super easy task. It's easier than understanding how this cassette piece or the video tapes work. Okay. But remember, in computer, everything is converted into binary number or binary signal, because number can be represented as, so this can be represented as signal. Maybe 1 0 1 1 1 0 0 1 0 and so on. So anytime data can be converted to a signal, and signal can be converted to binary number. And that is how it is stored. That is how it is transmitted. So we transmit this number. So for example, when I talk, what I talk is converted to a numbers like set of ones and zeros, and this set of ones and zeros representation is sent to you. That is how it works. And this full story we will look at, part of that story we will look at under topic 3, representing data. The rest of the transmission part we will look at in the networking subtopic. So networking topic is the biggest topic in your syllabus. No wonder, right? Okay, right. So everything for computer or any computing device like your smartphone, it's set of ones and zeros, even image, audio, video. Okay. So therefore, we need a way to measure the quantity of the data we keep, or binary data we keep. Right. So the smaller unit we use these days heavily is byte. So if you have one, remember it's in binary, so therefore your value can be either 1 or 0. There can't be anything else. So this is example 1 1 0 1 0 1 0 0. And this particular value is called a bit. So therefore, our data is set of bits. Right? So maybe thousands of bits or millions of bits. Okay. So 1 bit of data is the smallest unit. So that bit value can be 1 or 0. Right? And if you have 8 bit of data, 1, 2, 3, 4, 5, 6, 7, 8. So this 8 bit of data is we call 1 byte of data. 1 byte of data. It's something like 12 inches is 1 feet, or 10 centimeter, 100 centimeter is 1 meter, just a measure. Rather than saying millions of bits, I can say thousands of bytes. Okay. So 8 bit of data is called 1 byte. So then someone will ask why it is 8. So that is what we need. So all of a sudden you have to ask why. So you have to tell 10 is better than 8. Right? So we used to have 12 inches, right, feet system, and as humans, we have moved to the metric system, which is better, which is easier. 10 millimeter is 1 centimeter, 100 centimeter is 1 meter, 1000 meter is 1 kilometer. Why can't we use 10, 100,000, which is super easy for us as a humans? Why you are saying 8 bit is 1 byte? Why can't you say 10 bit is 1 byte? So you must have now, why you are attending these sessions, classes, or why you are doing this A-level ICT subject, or basically why you are studying to find answers for those questions. Understand why it is 8 bit. Why not it is 10 bit? Because you guys have to build the future. So in order to make the future, you must know the current reality. And you have to decide whether you want to change it, because the world is not in the same way forever. But you don't have to, you have to change it to the better, right? Not to the worse. So if you feel like 8 is not good, 10 is better, so you have to do that. The next generation of, right? You are the next generation. But if you feel like no, 8 is better than 10, of course, don't change it. Right? Don't change it. But first of all, you must know why it is 8, not 10. Okay. So that is the reason, not just blindly memorizing 8 bit is 1 byte. So that any fool can do it, any donkey can do it, memorizing things. Okay. Right. So the reason is, now maybe you have learned about these bit bytes in your O-level ICT, because these days kids learn IT right from grade 4, 5. Have you ever thought about it? Can someone give me the answer if you have ever thought about it, and if you have learned this in your O-level ICT? Of course, in O-level, usually we don't explain this. That is why we say ordinary level. Samanya pela. But when it comes to advanced level, you have to ask why. That is the difference in level. Can anyone tell me? If you have thought about it, or maybe your teachers have told it, why it is 8 bit, not 10 bits? Any guess at least? Any guessing? So I'm not expecting a perfect answer. I'm just checking whether, can you at least imagine something? Maybe. I'm not expecting the answer actually. If you give me the answer, it's a bonus. Why it is 8, not 10?
Because it's a double of 4.
It's a double of
4.
4. Yes. Right. So then you have to say why you use the word 4. Is it a magic number? So then you have the answer. 4 is the double of 2. So remember, we are talking about binary. Right? So remember, we use base 10. As humans, we use base 10. So that is why we say 3582. So this is 2. This is 80. This is 500. This is 3000. So these are ones, these are tens, these are hundreds, these are thousands. So we use base 10 number system, but computer use base 2. That is why in base 10 we have 0 to 9 digits. Base 2 we have 0 to 1. So remember, computer represent everything in binary. So therefore, in base 10, we like the word value, not we like, we work with 10. That is why it is 10 millimeter is 1 centimeter, 100 centimeter is 1 meter, 1000 meter is 1 kilometer is convenient because we work with base 10. But computer, remember, keep data in binary. 0 and 1 only. There's nothing called 7, 8. So in binary, just like 10, so we have 2. For base 10, what is 10 is for binary, it is 2. Right? So therefore, what we like is 2 to the power something. Of course, we want to break it into chunks so that we want to make it a smaller value. But that chunk must be not 10 to the power, 2 to the power. So what the computer engineers have selected is 2 to the power 3. 2 to the power 3 is 2 into 2 into 2. That is 8. So therefore, we take 8 as our unit, which makes sense, which makes perfect sense. Right? Which make perfect sense because we are working with base 2. Base 2. So therefore, computer engineers have decided, okay, let's take 8 bits as 1 byte. You can see 8 is closer to 10 also, right? Because next one is 16, right? Remember 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16. So they could have used either 16 or 8, but they have decided, okay, let's say 8 bit, not 16 bit. Okay, so we need a reasonable size thing, something closer to 10. So therefore we say 8 bit is 1 byte. Right? 8 bit is 1 byte. And before that, they use 4 bit also as 1 nibble. That is in early days. But these days we don't use it much, but you better remember that also. If you want, you can say half a byte is 1 nibble. Or 4 bit, you can consider it as 1 nibble. Or basically, 1 byte is 2 nibble. Right? But these days, usually we talk with bytes. Or 8 bit of a chunk is 1 byte. Okay. Sometimes we use the word also. But word is not a specific unit. So if you have a chunk of data that we consider as 1 unit by your computer, sometimes we use the word that is the word. That word can be 1 byte, or it can be 2 byte, 3 byte, 4 byte, and so on. So don't worry. If your exam paper use the word, its word length is say 2 byte. So that means they are talking about the chunk of 2 bytes. Okay, so therefore word is not a unit. Word is just a term we use, right? Just a term we use. So therefore that word length can be 1 byte, 2 byte, right? 4 byte, 16 byte, and so on. Right? So because there's no hard and fast value saying this much of byte is word. Because word is not a unit. Word is a term we use. Just like a word in our sentence. Okay. So chunk of bits that we take it as a, say, take it for processing for one time. So they will say the word length is this. We use this word when we look at the memory organization. Okay. Right. So therefore 8 bit is 1 byte. Okay. 8 bit we consider as 1 byte. So 8 bit of data is considered as 1 byte. And you know why? Because in binary, we are interested in 2 to the powers. We are not interested in 10 to the powers anymore. Right. So now, yes, byte is okay, but sometimes you get millions of bytes now. If it is 10 million bit, you get 1 million byte. But we like to say something like 2 kilometer, right? Maybe I like to say 20 kilometer rather than saying 20,000 meters. So kilo, right? And so on. So remember, you have the kilo, mega, giga. There's a smaller side also like milli, micro, nano. Okay, milli, micro, nano. So we have a system like that. So we have a similar system in measuring data also. So we use the same words. We have the kilo, we have the mega, we have the giga, we have the tera, and we have even the peta. Because now we are talking about huge data. Okay. But there's a difference. In normal systems like kilograms, kilometers, and so on, it is 10 to the power 3 or 1000 is kilo, right? 1000 gram is 1 kilogram. 1000 meters is 1 kilometer. But in data, remember we are interested in 2 to the power, it is 2 to the power 10 is kilo. So therefore, when someone says kilo, it is 1024. Right? 1020. For example, if you have 1024 byte, we can say 1 kilobyte. 1 kilobyte. So this is very important. It is not 1000, it is 1024. But of course, this is roughly equal to 1000, but exactly 1024. Okay. So then we have mega. In general case, like length and so on, we use 10 to the power 6 as mega. Or 1000 kilo is mega. Or 10 to the power 3 kilo is 1 mega. So similarly, this is 10 to the power. When it comes to bytes, 2 to the power 10 kilo is mega. So therefore, 2 to the power 10 into the kilo is again 2 to the power 10 byte. So therefore, 2 to the power 10 into 2 to the power 10, you know that in indices, these indices add together, 2 to the power 20 is mega. So just remember, 2 to the power 10 kilo is mega. So therefore, kilo is 2 to the power 10 again. So therefore, 2 to the power 10 into 2 to the power 10 is 10 plus 10 indices add together, 2 to the power 20. And similarly, this is 10 to the power 9 node. 1000 mega is giga. So here 2 to the power 10 mega is giga. So therefore, mega is 2 to the power 20. Another 2 to the power 10 is added. 2 to the power 30 is giga. So then 2 to the power, or the 2 to the power 10 giga is tera. So therefore, it's 2 to the power 40. And 2 to the power 10 giga tera is peta. Okay, so easier way to remember is, say 1 kilobyte is 1024 byte. 1 or 2 to the power 10 byte. Right. So 1 megabyte is 2 to the power 10 kilobyte. So kilobyte is again 2 to the power 10. So therefore, it's 2 to the power 20. 1 gigabyte is 2 to the power 10 megabyte. 2 to the power 10 megabyte. Megabyte is 2 to the power 20. So therefore, altogether it is 2 to the power 30. And this goes from 10, 20, 30, 40, 50, and so on. Right? Because this is 2 to the power 10 of kilo. So 2 to the power 10 into 2 to the power 10 is 2 to the power 20, and so on. Okay. But remember, this work for bytes only. Bytes only. If you are talking about the bits, then of course 1 kilobit is 1000 bit. So this is something you have to remember. Right? So if someone says 1 kilobits, that is 1000 bit. But if someone says 1 kilobyte, that is 1024 byte. So don't use this approach when it comes to bits. Okay, so because bits is still you have not break it into eights, portion of eights. But you have to, when someone says kilobyte, it is 2 to the power 10 byte, 2024 byte. But when someone says kilobit, that is 1000 bit. When someone say megabit, it is 1 million bit. or 10 to the power 6 bit. But when you say megabyte, 2 to the power 10 or 2 to the power 20 or 2 to the power 10 kilobyte or 2 to the power 20 byte. Okay. So it's very, very important. Right. So can you convert this one? Say my hard disk, let's assume, sorry, my memory is 8 gigabyte. Can you convert it into byte? You can put it into the chat, or you can just tell me. Convert 8 gigabyte. My memory is 8 gigabyte right now. Convert it into byte. How many bytes are there? How many bytes of capacity? How many bytes of data content can be kept in my memory? Remember, it's byte, not bits. And again, if it is not clear, you have to ask. I can explain it again. And again, try to ask why. So that is the most important thing that you have to ask. Why? At least ask from yourself. Or ask from others. Why? Because everything has a reason. Because if you don't understand the byte, kilo, mega, giga concept, then you can't do any calculations in the future when we look at the memory structure, organization, operating systems, and so on. So remember, anyone got the answer? Right. So 8 gigabyte means 8 into, remember giga is 2 to the power 10 is, just even 2 to the power 10 is kilo, 2 to the power 20 is mega, 2 to the power 30 is giga. So therefore 8 into 2 to the power 30 byte. Or you can say 8 is 2 to the power 3. Okay. So then it is 8 is 2 to the power 3 into 2 to the power 30 byte. And it is the 2 to the power 33 byte. So my memory has 2 to the power 33 byte of data, right? 2 to the power 33 byte of data can be kept. So what is 2 to the power 33? You must have some idea about that also, some feeling about it, right? Let me take my calculator. Say 2 to the power 30. Sorry, 2 to the power 33, 8 GB. 2 to the power 6 to the power y. 33. Right? It is this much of byte. This much of byte. This much of byte means this is million. 8,589 million and little bit more than that. Okay, byte of data. If it is bit, you have to multiply this by another 8. Okay, another 8. So then it is number of bits. So you can see it can keep this much of 8,589 million byte of data. And still now I'm running out of 8 GB. I'm thinking of upgrading it to 16 GB. Actually, I went there and checked the prices of the RAM chips because I want to pretty soon upgrade it to 16 GB because, sorry, 8 GB because so right now 8 GB is, I can survive, but not for some software. When I run some software, 8 GB is not enough. Okay, so you can see it's out of 8 GB, it's using 7.7 GB. Okay, 7.7 GB. So 8 GB means this much of byte, 8,589 million bytes. But that is also not enough for me now. Okay. Now, if you take hard disk, now they are pretty much in the terabyte level. Okay, terabyte level. Right. So you must be able to convert any value into any other format. Okay. So now you can see why the RAM is always something like 4 GB, 8 GB. Now, when I ask to upgrade, they will say, okay, you can upgrade it to maybe 12 GB or maybe 16 GB. Now, we can see why. Because these are also 2 to the powers. So, you don't have 10 GB RAM, 20 GB RAM. So, the same answer. Just like we have byte 2 to the power 8. And here also you can see frequently we work with 2 to the powers. Because that is the one that naturally fit into data, binary data. Right. Now, if you, I don't know whether you ever thought about it. I thought about it. So we always, almost all the time, right? For example, my operating system is 64-bit operating system. Some operating system we had 32-bit, right? So you can see 64, 32, 4, 8, 16, right? Because we use binary things. Things we measure in binary, things we kept in binary, things we process in binary. So therefore, naturally, it is 2 to the powers are coming, right? Everywhere. Everywhere you will see 2 to the powers. Okay. So likewise, so gradually you have to understand it, right? Gradually you have to understand it, then naturally you will remember it. Right? Your task is not remembering, it will be naturally remembered, right? If you understand it. Right. So that is how you measure your binary data. Bits, bytes, and of course kilobyte, megabyte, gigabyte, terabyte, petabyte. You have to remember is 1024 kilo is mega, 1024 mega is giga, 1024 giga is tera, 1024 tera is peta. Or 2 to the power 10 byte is kilo, 2 to the power 10 kilo is mega, 2 to the power 10 mega is giga, 2 to the power 10 giga is tera, 2 to the power 10 tera is peta. So that is why every time it is incremented by 10, because when you multiply, indices add. Right? Indices add. So then you have nothing to worry. You know the reason, you know the mechanism, right? You know why. So then why do you want to worry? Right? So when exams are nearing, you will be really relaxed. Right? You will be really relaxed because you study in the proper way. Right? So at the end, there are 2 types of students. Students who study in the proper way, they will get good results, they will be happy, they will be the future software engineers, IT professionals, and so on, or whatever, right? I don't want everyone to that just because you are doing IT, I'm not asking you to be a IT field, but whatever the field, right? Maybe a accountant, but others, when the exams are nearing and so on, they will be stressed, they will get less results, right? So because they are not doing it properly. So then you no one to blame. It is blame yourself because you are not doing it properly. You are doing it in the wrong way. So that you cannot survive in advanced level like that. Maybe O level. Right. So that is how you measure our binary data. Okay. But remember, when it comes to bits, 1000 bit is 1 kilobit. But bytes, 1024 byte is 1 kilobyte and so on. Okay. So that is super, super important. Okay. So that is why sometimes these service providers like Dialog, Mobitel, and so on, sometimes they use megabit per second. Sometimes they say megabyte per second. So some people don't know the difference. So they just compare. You can't compare megabit and megabyte. You have to convert it and compare. So they want to. So for example, let's assume that. Let's just assume, right? So X has a lesser data speed. Say, let's assume just this is not the reality, right? So let's assume Hutch has a lesser data speed, bandwidth. So then while Dialog and Mobitel says megabyte per second, Hutch will say their value in megabit per second. Because then if Dialog says 8 megabyte per second, Hutch will say 10 megabit per second. But in reality, that Dialog is faster. So because you can't compare megabits and megabytes. Okay. So that is sometimes people used to cheat others because not everyone is aware of these things. Okay. Right. So that is how your data is stored, and that is how you measure our binary data, because everything is set of ones and zeros. Okay. Now let's again look at, now remember we try to understand things better and better, okay, more and more seriously by each and every slide. Now let's see how the data is processed. So remember, we process data using software or programs. And we write programs these days using high level languages, programming languages like Java, C#, Python, C, right, PHP, and so on. So this is a Python program that we will be writing later, right, when we are doing the programming. So this is not, remember the logic key is also set of ones and zeros. So this is a funny thing, right? Your data is also set of ones and zero. Your logic must also be set of ones and zeros, because logic means control signals. So control signals are also like this. Okay. So those are the type of signals that is sent through your logic gates in your microprocessor. These are the type of signals that represent data. These are the type of signal that represent my processing instructions. So at the beginning, you may not understand this. So don't worry. Still, we just touch the concept of processing. So that is why we have the data representation as a third topic, data processing as the fourth topic, that is logic, Boolean logic. So, but you can see this is not this kind of a signal, right? Or this kind of 1-0 representation of a control. What we write is something close to English, right? If, else, while, print, right? Assign values, and so on. So this has to be converted to this kind of set of ones and zeros. So set of signals like this, or commands like this. And those signals get processed by, or your data is processed by using these control signals to get your result. So therefore, ultimately, your program will result in set of control signals. That is why you have the control unit in your computer, microprocessor. Okay. So it generates those control signals. That is what happens at the program running. But what we write is not these kind of set of ones and zeros. What we write is something like this. So it will be initially converted to something called assembly code, which is low level than your programming code, but still it is not ones and zeros. It has some English-like terms and little bit higher level. So that is what happens when you do something called compile or interpret. For example, when you use Python, you have to download Python interpreter. Then you write your code, then you run it. When you run it, basically, first it is interpreted to this kind of a code. That of course, we don't look at the code. We don't want to look at the code, but that is what happens. And then it is again translated to control signals at very hardware level with the use of firmware and so on. So this is pretty much under your hardware. This is pretty much your compiler. Remember, one of the system software is translators. So you can see this is done by one of the system utility, compiler or interpreter. And then this code is more familiar for your computer hardware. So this is not very familiar for the hardware. This is something hardware can understand somewhat, but still your microprocessor can understand only this level of things. Your logic gates can understand only this, whether electricity is there or not at that particular time. And then it will decide whether this is 1 or 0. And we have these kind of circuits, right? So that is the long story that we are going to learn. So therefore, it has to be converted to this level gradually. First, it converted to something closer to the machine, but then still it is not binary code. So then it is converted to this in the next step at the running time. Then we say our program is now running and we are getting the outputs and so on. Okay. So it's very important to understand this stepwise process. So this is converted to assembly code at the compile or interpreter time, and at runtime, sometimes we just compile and run it at the same time, but it happens in 2 steps. And then it's generate these set of ones and zeros, which are converted to those signals. These signals goes to these boot circuits, and you get different set of signals. That is your result or the output. Maybe this is your the photo that you just took it. Maybe this is your beautified photo, applying some filters and so on. Okay. So maybe you just input some value. Now it is bold, italics, word processor is doing that. Maybe the original audio, now it is the noise is cancelled and enhanced audio. Okay. Try to understand right? Don't worry, we will look at this more and more ways, more and more steps we will look at while we are doing your A-level ICT syllabus. Okay. So how to write this kind of a code we will learn, right? So of course, otherwise you can't start it. Okay. And so on. Okay. Right. So this part we have already discussed. So I just added it again to this one also. So remember, the computer use hardware, the computer hardware use the component architecture. This is, anyway, we have already covered in the second day and introduction to computer. I just added the same slides again here because it's so important. And remember, computer hardware is set of components, and these components can integrate or communicate in well-defined interfaces. So that is why you have the USB interface, HDMI interface, right? And so on. Okay, we will look at some more interfaces, internal interfaces, right? Like SATA cables, SATA interface, and so on. Okay. So remember the advantage of component architecture: easy to upgrade, easy to manufacture. We can different manufacturers develop manufacture different components. Easy to troubleshoot, easy to replace. Right. So that is why when you have issues with computers, sometimes you just take it. You don't have to keep it there. If it is a radio or television, they will ask keep it. I will have a look at it. But computer, most of the time, they will say, okay, just wait 10 minutes. I will tell you the issue. Then they will say, okay, we have your RAM is not burned or corrupted. So we have to replace the RAM. So you take the computer home. Why? Component architecture. Okay. Unless you have issue with motherboard, usually they can do that fix within less than 15 minutes. Of course, if it is your motherboard, that is a different story, right? Sometimes you have to replace the entire motherboard. Okay. So easy to troubleshoot, easy to replace, easy to upgrade, right? Easy to design and manufacture, because they have agreed this is what processor is doing, this is what SSD is doing, and motherboard support those common standards. It doesn't care whether your monitor is Samsung or right LG. Whether your processor is, of course, motherboard has to compatible with the processor. That is a different story because motherboard has to compatible with processor. But especially, it doesn't matter whether your SSD is Kingston or something else. Your network card is right Cisco or something else. Huawei. So there are well-defined interfaces. And additional compatibility is supported by firmware for the operating system. Okay. Right. So what are the hardware components? We look at those things, right? Input devices, output devices, storage, and processor. Right. So we look at this. I'm not going to look at this again, but I just included it as because we are looking at the computer architecture, right? So input devices, input data and commands, right? And the output devices output the results or the information. Now you must be really serious about these answers, right? Your main memory keep the currently executing program segments and related data. Okay. Your secondary storage permanently store your data and programs. Right. So RAM keep the currently running program segments and related data. ROM keep your firmware, the system or the main firmware. Okay. BIOS and CMOS. Now you know those two words also, BIOS and CMOS. And your processor does the processing and controlling. Right? So that is why you have the ALU processing control unit. Registries are part of the ALU. Okay. So we will get into more details about the processing and memory, right, in the next few slides. Okay. Right. So then the motherboard is holding these things together. Right. So that is why we call it motherboard. Holding these things together. Sometimes we call it main board, system board, main circuit board, and so on. Okay. So it holds things together by providing standard interfaces, slots to fix those things. So this is how it looks. Don't worry, right? If you don't, of course, some of you guys are pretty much familiar with these things. Sometimes you, right, you may have fixed your graphic cards and so on, right? So, but others may be a little bit not new to this, but don't worry, we will look at what are these slots and so on later on. Okay, so this is just to give you the exposure to this. Okay, and this is little bit older motherboard anyway. So the modern motherboards have slightly different things as well. Okay, right. So we stop at this point. So we are about halfway in the computer architecture, right? Not yeah, more than 1/3. So this is a slightly bigger topic, right? So next time, most probably we will finish your topic 1 because we have to look at the legal and ethical aspect we discuss of the IT. Those are also important, right? So we have to not only we need to have the technical knowledge, we need to have the usages, ethical things, social impact, and everything, right? So that is what we need from professionals, right? So we stop at this point. So we will finish our topic 1 as well as then we will come back and continue our architecture. After architecture, we have to separately look at the input-output devices, the storage devices, and again microprocessor in more details later. So they because this topic 2 is slightly bigger topic, so it will take another at least three sessions to finish the topic 2. Then we will start in topic 4. Before going for the representing data, that is topic 3, we start topic 4, the processing part, for some reasons, right? So we after halfway in the topic 3, topic 4, we will go to the topic 2. So then parallelly we will finish topic 2, topic 3 and 4 together. So topic 2 will be over by end of October, maybe first week of November. But then we will be focusing on just like we focus on topic 1 and 2 together, we will be focusing on topic 3 and 4 together. Right. So once topic 3 and 4 is finished, only we can go to operating system or the topic 5. From that point onward, we will be doing one topic at a time because those are big topics. Okay. So 1, 2 we do parallelly, 3, 4 we do parallelly, then we do only one topic at a time. Okay. Right. So we stop at this point. Right. Thank you. How can we write? What do you mean by write the note? So the note is in the Google Classroom, right? So you don't have to take notes because the note is there. But if you want to take additional notes, yes, you can take your own notes, but usually you don't have to, right? Maybe after the session, you can refer the note and prepare a short note or something like a mind map or something. Is it your question or something else? Yeah, maybe that is your question. Okay. So the note is available in the Google Classroom. So those who have done this payment, you have the access because I have removed the Google Classroom access, right? So only the students who have done the payment will be getting Google Classroom access. And also from November, only those who have done the payment only because we have to formalize things. The AL-ICT is not a joke, it's a serious thing, right? So we need only the serious people, otherwise students come and go, and right, no one becomes then serious. Okay, so once you do your payment, you have to inform through send me the screenshot or the camera copy of your payment slips. Make sure you do it immediately once you do the payment, right? Don't do the payment today and send me the screenshot next day, because sometimes I find it difficult to recognize which students has done it, because there are some other classes also. So once you do the October payment, you have to inform me with your email address. So then you will be getting the Google Classroom access and also your previous video recordings and everything again. Okay, so that is how it goes in other classes also, right? So right. So we stop at this point, right? I hope your question is that, right? How to get notes or how to take your notes. Okay, and we stop at this point, right? Thank you.